So we're now ready to talk about one of the most important types of operators in the Flux class, which is the so-called terminal operators. And as the name implies, these terminate a Flux stream and then trigger all the processing of the operators in the stream. And we're going to focus here on the subscribe operator, which is a really, really, really important operator in Fluxes and in reactive programming in general. So what does the subscribe operator do? Well, it actually does a boatload of things, but we'll start out with the high-level thing. It subscribes a consumer to this particular flux. And remember, these things can be chained together, so there could actually be an originating source, and it goes through a bunch of intermediate transformations and filtering and so on, and end up ultimately at some kind of subscriber or consumer sync at the end of that process. It's got several parameters. There's actually many overloaded variants of this. I'm going to focus on the one that's the most comprehensive. Well, not even the most comprehensive, the most commonly comprehensive, as you'll see. And this particular operator defines 3 parameters, 2 consumers, 1 runnable. And this operator will consume all elements in the sequence that complete normally. It will handle any errors that may occur, or error that may occur. And it also can be used to react to completion. And that's what those 3 parameters do. So you can see that you have a consumer to consume the data normally, a consumer to consume an error, and a runnable to complete the results. Like end of file. Think of it like end of file. And this particular use of subscribe, unlike some variants we'll talk about later, requests unbounded demand. And what that basically says is it's telling the publisher, the producer, send the data as quickly as you deem necessary, and I will keep up, which might or might not be the case, in reality, but that's what it's saying. We'll see that there's other variants that give you a way to limit the amount of data that you get sent to you, which is called back pressure. We'll talk about that later. Signals that are emitted to subscribe are represented by the following regular expression. We've talked about this before, but now it'll make a lot more sense because we're finally seeing it in context. You can have 0 or more calls to on next, 0 to infinite number of calls to on next. That's what the little star means. It doesn't mean multiplication. It means the regular expression 0 or infinite, followed by optionally on complete or on error. So those are mutually exclusive, and those are optional. They may or may not occur. So that's how you read this thing. What's returned from subscribe is a really curious type called disposable. And disposable can be used to indicate that a task or a resource can be canceled and disposed. It's basically a way of being able to help the garbage collector free stuff up when it's no longer needed. And you can actually use something called a disposable composite, which is pretty cool. And you can register a whole bunch of different kinds of handles or various kinds of references like publisher, scheduler, subscriber, blah, blah, blah. You can put all of those things into a single disposable composite or composite disposable, and then you can dispose of them in one fell swoop. It's kind of like, group delete, if you will. The important thing about subscribe is it triggers all the processing in a chain. So in that sense, it's very, very much like the terminal operations that we have in Java Java streams, like collect or reduce or find first or whatnot. So nothing starts to run, literally nothing does anything until subscribe is hit. And sometimes subscribe is hit in a very, implicit way, like if someone calls get block or something like that, or block optional, and so on. So there's various ways you can get subscribe to be used to initiate the processing. So this particular example, which we'll look at later, is going to have a big fraction list. It's going to take each of the big fractions, turn it into a stream, a Flux stream of big fractions. It'll multiply that stream by having each of the big fractions multiplied by some constant. And then none of that happens, of course, until subscribe is hit. And what subscribe does is it starts the wheels in motion. It says, start your engines. And then, depending on what has happened, different parts of the parameters that are passed in will be invoked. Because keep in mind that these are all basically lambda expressions. So the first lambda expression is used to handle normal processing. And you can see what normal processing does in this context is it simply takes the fraction that's coming through subscribe and appends it to the end of the string buffer or string builder. If something goes wrong, we're going to append the string error, and we're going to display the results, which I omitted in the interest of space. And when we finish normally, sort of like end of file, in that case, we're going to go ahead and convert the string builder to a string and then go ahead and display it. We would also do that here in the ... part because we want to display the results. But I couldn't fit that on the slide. We'll see that when we get to the case study. So those are the three different types of things we do. We handle normal processing by appending things to the string builder. Error appends error and prints the results. And then if we complete normally, we convert the string builder to a string and print the results. Now, here's the thing that throws you for a loop, and this is what motivated my async task barrier helper class for all my examples. Calling this method will not block the caller thread. And this is always the case, but it's more obvious the case if you have asynchronous streams. In other words, ones that have used the subscribe on or publish on method in order to actually have things running in background threads. So what'll happen in that case is subscribe will just return, stuff will be cranking away in the background, and if you don't have anything else to keep you from going any further, you could very well fall off the end of your program, in which case the main thread would shut down, which would then cause everything else to shut down, which is probably not what you want. So that's why we typically use the async task barrier to run all of our tests so that nothing will shut down until everything is, or the main thread won't shut down until everything else is done. So there's no blocking. Now, sometimes when you have a synchronous Flux stream, it doesn't matter that there's no blocking because it's all done by the time subscribe is finished because there's no asynchrony. But that's just a quirk of the way that processing works in streams. And therefore, because of these semantics, that's why we had the async task barrier framework to make things stick around in the main thread until all the other asynchronous processing was done. Now, there's a whole bunch of other versions of subscribe. There's some that takes one parameter, some that takes two parameters, some that takes more than three parameters. Here's one of the interesting ones we will come back to and look at later. This one allows you to pass in a custom consumer, which is going to implement the subscription interface. And you can do this in order to be able to apply back pressure. If you just use the 3-parameter version of this guy, subscribe, then no back pressure is applied. It'll just have the subscriber sending the data as fast as it can or as fast as it wants to, which could be bad because you could overrun the processing resources of the subscriber if you're sending data too quickly. This is especially true if you have one or more threads publishing data into a Flux stream and maybe only one thread subscribing and processing it. You could have more data than you could handle, which has problems, which we'll talk about later. But you can also pass in this subscription mechanism, and in that case, whoever writes this thing, can dictate how much data is sent in one fell swoop. So you could say, send me 10 elements of data. And once I'm done, send me the next 10 elements of data. And once I'm done processing that, send me the next 10 elements of data. So that's what's called back pressure or flow control. RxJava has the same concept that Project Reactor does. There's a few subtle variants, but it's basically the same idea. Okay, so that's the end of the terminal operator discussion in the Flux class. Very, very important to understand subscribe. And as we sometimes have seen with Java streams, if you forget to put a terminal operator, nothing happens. Same thing is true with Project Reactor or RxJava. If you don't put a terminal operator, then you'll be scratching your head going, why isn't this thing doing anything? Now, again, remember, sometimes the terminal operators are implicit. Like if you make blocking calls, under the hood, they're calling subscribe and doing some magic that we'll talk about later. But that's not the way that they're, that's also using subscribe. So it's always taking place if you want things to run.